So I want to practice graphing some rational functions. And right here we have the function 3x minus 3 over x minus 2. And I have a strategy for graphing these rational functions. And the first thing I like to do is determine if there is symmetry. If it's an even function, then there's y-axis symmetry. And if it's a non-function, there's symmetry about the origin. So if I already know what f of x is, I'm going to find what f of negative x is, and I also want to find out what negative f of x is. So f of negative x would be putting a negative x in place of x. So that would boil down to negative 3x minus 3 over negative x minus 2. And so in order for there to be, in order for it to be an even function, or for there to be symmetry about the y-axis, what I get here, f of x and negative f of x, or excuse me, f of negative x would need to be equal. And since they're not equal, this is not even. Okay, and so for negative f of x, you literally write down your original f of x and just make it negative. So we had 3x minus 3 over x minus 2. And that becomes negative 3x plus 3 over x minus 2, or it could be 3x minus 3 over negative x plus 2. Okay, but neither of these is the same as what f of negative x is. See, in order for it to be odd, f of negative x and negative f of x must be equal. So this is not odd either. In step 2, I like to find the x and y intercepts. Well, I'm going to start with the y-intercept. Really, that's step 2, y-intercept. And you find the y-intercept by plugging in 0 for x. So basically f of 0. So since f of x was 3x minus 3 over x minus 2, then f of 0 is 3 times 0 minus 3 over 0 minus 2. So I get negative 3 over negative 2, which is positive 3 halves. So that would be the point of the coordinate 0, 3 halves. So step 3, let's find the x-intercept. And that's by plugging 0 in for y. Well, so f of x, again, was 3x minus 3 over x minus 2. F of x equals is the same thing as saying y equals. So what I want to do is say 0 equals 3x minus 3 over x minus 2. And this is where people start freaking out. They're like, how am I going to solve for x? Well, it's actually pretty easy. Think of this as cross multiplication for me. And 0 times x minus 2 and 1 times x minus 3. Well, all you end up with is 0 equals 3x minus 3. And from there, it's super simple to solve for x. You get that x equals 1. So that is the coordinate 1, 0. That's our x-intercept. Okay? So step 4 is to look and see if there is a vertical asymptote. What is the vertical asymptote? So remember, this is our function right here, so I'm not going to write it down. I'm not going to write it down again. I'm just going to set the denominator equal to 0. And so that's x minus 2 equals 0, so x equals 2 is the vertical asymptote. Now when I graph this, I'm going to want to do a dotted line. Okay, step 5 is there a horizontal asymptote? If there is, what is it? Well, let's look at that function. Not top heavy, not bottom heavy. The power in the numerator is the same as the power in the denominator. So all you do is simplify. You simplify and you get y equals 3. And again, this is going to be a dotted line. So since there is a horizontal asymptote, there is not a slant asymptote. But do remember, in order for there to be a slant asymptote, the degree of the numerator has to be 1 more than the degree of the denominator. Okay, and so for step 7, I like to figure out some points. Well, I already know a few points, right? I already know that when I plug 0 in for x, I get 3/2 for y. And when I plug 0 in for y, I get 1 for x. So let's start kind of plotting this thing out. Okay, let's see. There's a vertical asymptote at x equals 2. There's a horizontal asymptote at y equals 3. See how we did dotted lines for that. I already know that we have a point at 0, 3/2. So 3/2 is the same as 1.5, which is right here. That's our y-intercept. And then there's a point at 1, 0, which is right here. And so our graph on this left side, and I don't like the way I've applied that, our graph on this left side of the vertical asymptote is fine. I have 2 points on that side of the vertical asymptote already. I don't have any points on that right side of the vertical asymptote over here. So I want to choose some x values on the other side of that x value of 2. So maybe like 3 and 4. Okay, it needs to be on that right side of 2. If I plug 3 into the original function, that original function, 3x minus 3, so 3 times 3 is 9, 9 minus 3 is 6, and then 3 minus 2 is 1, so I get a value of 6. And if I plug 4 into the function, to the original function, I get 9 over 2, or it'll be easier to think about it as 4.5. So 3, 6, 1, 2, 3, okay, and then 1, 2, 3, 4, 5, 6. So 3, 6 is right here, and I changed my tool there, and then 4, 6, excuse me, for the x value of 4, it's 4 halves. So 1, 2, 3, 4 and a half. So about right there. And that's all you need.